let's go through some questions from the chapter set theory. Let's solve a little bit of questions. Now move on to the first question. Which of the following sets has no elements? So we talked that null sets have 0 elements. Single set have 1 element. Universal set have all the elements. Power set have all subsets, and null sets have 0 elements, right? Now, if A is equal to 1, 2, 3, 4, 5 and B is equal to 3, 4, 5, 6, 7, what is A intersection B? So, what does intersection do? Intersection means the element which are common in both A and B. Let's see what we have in A. We have 1, 2, 3, 4, 5. In B, we have 3, 4, 5, 6, 7. So 3, 4, 5 are common in both A and B. So the answer for this question is 3, 4 and 5. So we could actually do this by using a Venn diagram. We have A and B and we have a universal set, right? U. This is A and this is B. We have A as 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. Now here we have 3, 4, 5, 6 and 7. So A intersection B is 3, 4, 5. Now given sets A is equal to X, this is such that X is an odd number less than 10. What is A in roster form? So A is equal to X such that X is an odd number less than 10. We have 1, 3, 5, 7 and 9. These are the odd numbers which are less than 10 and the answer is right here. Now, if A is equal to 1, 2, 3 and B is equal to 3, 4, 5, what is A union B? So, A union B is equal to 1, 2, we have 3 common, so we'll just write it once, 3, 4, 5. So, the set A union B is equal to 1, 2, 3, 4, 5. Now, what is the power set of the set AB? So, we have AB, we'll start with the null set, right? So, we have a null set, then we talk with the singleton sets here, we have A and set B, and then we have the set AB, right? This is the power set of AB, so it's given here and this is the right answer. Now, how many subsets does the set 1, 2, 3, 4, 5 have? So, how many subsets does the set 1, 2, 3, 4, 5? How many elements do we have? 1, 2, 3, 4, 5 elements, right? So, how do we find the number of subsets? We have the number of subsets is equal to 2 raised to n. Now, what is n here? N is the number of elements, right? This is equal to 2 raised to number of elements is 5, which is equal to 32. 2 raised to 5, right? That means 2 into 2 into 2 into 2 into 2. We have 4, 8, 8 to 16 and 16 into 2, which is 32. So that the right answer is 32 here. Now, let's move on to the next question. If A is equal to X such that X is a prime number less than 10. So let's write the roster form first. We have A is equal to X such that X is a prime number less than 10. So what are the prime numbers less than 10? We have 2, 3, 5 and 7. And B is equal to X such that X is an even number less than 10. So we have 2, 4, 6, 8, right? Now what is A intersection B? So A intersection B means what are common in both A and B? We have 2 common here and 3, 5, 7, no. So 2 is the answer for this question. Now, which of the following is an equivalent set to set ABC? Which of the following is an equivalent set to set ABC? We have to find the equivalent set, which means the number of, in equivalent sets, the number of elements should be equal. Here we have B, C, D with 3 elements, AB with 2, this with 4 and this with 2. So obviously this is the right answer because they have 3 elements each. For a set to be equal sets, we need the exact same elements in the both sets. But whereas the set is said to be equivalent set where there is a number of elements are equal in both of the sets. Now let's move on to the next question. If A is equal to 1, 2, 3, 4, 5, 3, 4 and B is equal to 2, 4, 6, 8, what is A minus B? So what is happening here? So basically we have, let's draw a Venn diagram. Okay, this is the universal set, right? Now A have 1, 2, 3, 4 and B have 2, 4, 6, 8. So B, I'm drawing it like 2, 4 is there and 6 and 8. This is A and this is B, right? Now we have to subtract B from A. That means we are subtracting this portion out. So what do we have rest here? We have the remaining portion as this. The portion which is marked in red is the remaining portion, which is actually 1 and 3. In another way, we could say that A is equal to 1, 2, 3, 4 and B is equal to 2, 4, 6, 8. 2, 4, 6, 8. We are subtracting B from A. So what are the elements which are in B which is also in A, which is 2 and 4. So what is the remaining? We have 1 and 3 as the remaining. So next question. The complement of the set 1, 2, 3, 4, 5 with respect to the universal set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is. So the universal set here is given from the numbers 1 to 10 and we have a set, let's call it A, is equal to 1, 2, 3, 4 and 5. So what is the complement of set A? A complement is equal to actually U minus A. What does this mean? Everything which is in the universal set but not in the A, set A, right? So we have 1, 2, 3, 4, 5 in the universal set, no A set, so the remaining is 6, 7, 8, 9, 10, right? So 6, 7, 8, 9, 10 is the right answer. Now let's move on to the next question. How many proper subset does the set A, B, C have? So here we are talking about proper subsets, okay? Proper subsets is actually, when you talk about the subsets in, other than the null sets. So we have A, B, C. The number of subsets is equal to, number of subsets is equal to 2 raised to 8, no 2 raised to 3 which is equal to 8, right? We have 3 elements, so it's 2 raised to 3 which is 8. Now proper subsets means this 8 minus 1 which is 7. So the equation for the number of proper subsets is equal to 2 raised to n minus 1, where n is the number of elements. So let's move on to the next question. If A is equal to 1, 2, 3 and B is equal to 2, 3, 4, what is A intersection B complement? So basically here the universal set is not given. We could take the universal set to be 1, 2, 3 and 4. I'm just assuming. Now if A is equal to, here we have A is equal to 1, 2, 3 and we have B is equal to 2, 3, 4, right? Now what is B complement? B complement is 1 here and A intersection B complement would be just 1, which is not in the answer. So I hope that this is a mistake. B complement, we have to take A intersection B. So what is A intersection B? We have 2, 3 here, we have 2, 3 here too. So the answer is 2 and 3, right? Now let's move on to the next question. Which of the following sets are disjoint? So what are disjoint sets? So disjoint sets are these sets which have nothing in common. Let's see, 1, 2, 3, 4, 5, 6. Yes, this is the disjoint set. It has nothing in common. Let's see the other sets too. We have 1, 2, 3 and 3, 4, 5. We have 3 in common, so it's not a disjoint set. We have 1, 2, 3 and 2, 3, 4. 2 and 3 are common in both here. We have 1, 2, 3 and 1, 2, 3, 4, 5. Here 1, 2, 3 is common in both the sets, so these not disjoint sets. The answer is the first choice. Now, let's move on to the next question. If A is equal to set of A, B, C and B is equal to set of B, C, D, what is the cardinality of A union B? Cardinality means the number of elements, okay? So, A is equal to A, B, C and B is equal to B, C, D. So, what is A union B? We have A, we have B, we have C and we have D. All the other things, B is repeating and C is repeating. So, we have 1, 2, 3 and 4. So, A union B have 4 elements and 4 is the cardinality of the given set. Now, let's move on to the next question. If A is equal to 1, 2, 3 and B is equal to 3, 4, 5, what is A cross B? So, basically A into B or A cross B is actually, it's not in the syllabus, but I think it's a very important thing for learn in set theory. We have A cross B means we are multiplying set A with set B, right? So, set A we have 1, 2, 3 and set B we have 3, 4, 5. So, we are multiplying every single element from this set to the other set. So, what we do is we will get a set of 1 and 3. We call this ordered pair. When we put it in a circular bracket, we call it an ordered pair. So, 1, 3, then we have 1, 4, then we have 1, 5. Same way we have 2, 3. We have 2, 4, we have 2, 5, then we have 3, 3, no 3, yeah, should we have 3, 3? Yes. Now we have 3, 4 and then we have 3, 5. So this is A cross B, that is A multiplied by B. So this is the answer for this question. Now let's move on to the next question. If A is equal to set 1, 2, 3 and B is equal to set 2, 3, 4, what is A cross B? So again we have A is equal to 1, 2, 3 and B is equal to 2, 3, 4. How do we find A cross B or A into B? We have ordered pair 1, 2, again 1, 3, we have 1, 4, then we have 2, 3, 2, 2, 2, 3, 2, 4, we have 3, 3, 3, 4, 3, 2, 3, 3 and 3, 4. So this is the set A cross B and this is the answer for it. Now let's move on to the next question. If A is equal to X such that X is an even number less than 10. So A is equal to X such that X is an even number less than 10. That means A is equal to 2, 4, 6 and 8. Now B is equal to X such that X is a multiple of 3 less than 10. So X is a multiple of 3. So multiples of 3 which are less than 10, we have 3, we have 6, we have 9, right? Now what is A intersection B? So where does it intersect? They intersect at 6. There is no point of intersection other than this, right? So 6 is the right answer for this question. Now if A equal to X such that X is a consonant in the word teacher and B equal to X such that B is a vowel in the word teacher, what is A union B? So A is equal to X such that X is a consonant in the word teacher. So other than all the vowels, what are the vowels? A, E, I, O, U. Other than that, what do we have here? We have T, C, H and R. So A is equal to T, C, H, R. This is the set A. Now B is equal to X such that X is a vowel in the word teacher. So what are the vowels in the word teacher? We have E and A. It's again E, so we'll write E and A. Now we have to find A union B. A union B would be equal to T, E, A, C, H, R, right? So we have T, C, H, R, E, A or T, E, A, C, H, R. Now let's move on to the next question. which if A is equal to 1, 2, 3 and B is equal to 2, 3, 4, what is A minus B complement if U or universal set is equal to 1, 2, 3, 4? So let's write this down. We have A is equal to 1, 2, 3. We have B is equal to 2, 3 and 4, and we have B complement is equal to 1, right? B complement is 1. Why? Because this is the universal set. 1, 2, 3, 4 is the universal set, and the things which is there, which is not there in B but there in U is 1, right? Now we have to do A minus B complement. So we subtract B complement from A and we'll get 2, 3. So 2, 3 is the answer. Now let's move on to the last question from this chapter. If A is equal to X such that X is a positive integer less than 5 and B is equal to X such that X is an odd number less than 5, what is A intersection B? So A is equal to X such that X is a positive integer less than 5. So we have 1, 2, 3 and 4. And B is equal to X such that X is an odd number less than 5. So we have 1 and 3. What is A intersection B? We have 1 and 3 here, we have 1 and 3 here. So 1 and 3 is the intersection of A and B. So we solved like 20 questions from the chapter set theory, and I hope all the concepts are very clear because these are some pretty straightforward questions from this chapter, and I hope you all are done with this.